Okay, so I will start, and thanks a lot for inviting me. I was presented already before, and since we are in a shortage of time, I will just start. So I will give you a brief keynote that is titled "The Day at the Zoo of NLP for Requirements Engineering, Ambiguity and Other Animals," and we will do a quick tour on what are the typical tasks that in which NLP is applied to requirements engineering. And then we will see some, I will tell you some stories about my experience in applying NLP to requirements problems, okay? So let's start. Everyone who's written a paper on application of NLP to requirements engineering has also written this sentence: requirements are typically written in natural language. And we have a lot of references to support that. And in particular, the most recent one coming from the Napier survey that I invite you to check on the internet from 2019 is showing that about 52% of companies, this is a large survey made all over the world with several companies, most of the companies are using natural language requirements. But the issue is what type of natural language? Well, requirements can come in very different forms. You can see some examples here. Like the typical example is the user story that is quite common today. For example, as a user, I want to share pictures so that my friends would see them. But in industry, it's also very common to see the classical SHAR requirements like this one. If track data at least to the location where the relevant MANs are not available on board, the MA shall be rejected. This is a real requirement. Of course, it's very hard to understand if you don't have the domain knowledge that is required to make sense of these requirements. And you have also other different formats, for example, unstructured requirements, in which you have long paragraphs describing what the system is expected to do, or more structured use cases. But we have also other types of documents that are within the scope of requirements engineering and NLP applied to requirements engineering. For example, users feedback. Users feedback, for example, the app reviews actually include relevant information that can be used for requirements engineering, for product improvement, for example. The same holds for bug reports and issue tracking systems, so that this content can be useful to requirements engineers. And even legal documents, because we know that our software in many cases need to abide to certain rules, to certain legal constraints. And so legal constraints become requirements for our software. So you see that when we speak about natural language requirements, we speak about different types of documents. And while we speak about different types of documents, we also speak about different types of tasks. Okay, and in this keynote, I will show you what are the most typical tasks that are researched in the literature of NLP for requirements engineering, and some pointers to papers that are addressing them, to papers that have been published in the last 2 years. So if you want to check, you see this is fresh research, let's say. So the typical first task is classification. You have a large requirement set and you want to better manage this set of requirements. So you do a classification, for example, by classifying it into functional categories like user interface communication, non-functional ones, or more fine-grained topics. This can be useful to create boxes, let's say, for your requirements, so to have a better management and the composition, and also help later retrieval, because it may be the case that you want to reuse these requirements in other projects. One recent paper about classification is this one about Norbert, that is able to achieve a classification with an F1 score up to 92%, and they use BERT. It was published at RE 2020, okay? This is a classical problem, very good performance, okay? So real problems can be actually addressed today with good performance. I mentioned retrieval. You may want to retrieve your requirements. Why? Because a new customer can come after you've developed a set of products and you want to reuse as much as possible of the products that you developed. And therefore, you use your requirements database, let's say, as you would use Google. So the customer requirements become a query. You get the existing requirements. You are able to link the requirement to your software, and then you can provide a tailored product. Similarly, in other cases in which you have public procurement documents, so you want to check whether your requirements and therefore your system actually cover, or to what extent do they cover, the public procurement documents. So in these cases, it goes without saying, you can use NLP techniques, and more specifically information retrieval techniques. Here we did a recent paper actually with Abbas and Merdad. It's still under review, and it was checking the relationship between similar requirements and similar software in a requirements retrieval scenario. In the beginning, it seemed that that TF-IDF was the best solution, but in the end it was BERT with a correlation around 0.6, so medium-high correlation. There is another very typical task of NLP-4RE, that is tracing. In my software process, I don't just produce requirements and software, but I produce also several other artifacts like models and other documentation. And I want, of course, to trace this documentation together, and as this can be useful for external assessment. For example, for safety critical products, you are obliged to trace all of your requirements to the architecture and down to the source code, but also for doing impact analysis and refactoring. If I change this requirement, what is the impact on my software? Okay. And doing this tracing automatically can be supported by NLP techniques. And of course, NLP techniques can also support the identification of wrong links that have been manually written, or the inclusion of links that you forgot to include, okay? This is very important because tracing is extremely boring and error prone. I've been doing tracing myself when I was working in a company. I can assure you is an activity that you don't want to do entirely manually, okay? A recent paper about this was at ASE actually, and they reached an F2 score around 70% and MAP around 80%. And of course, also in this case, they're using BERT. So basically, we see that in recent years, this is actually the solution also for requirements engineering problems, at least for the ones that we've seen up to now. Another task is defect detection. This is also very easy to understand. You have your requirements, you want them to be unambiguous, clear, so that everyone who reads them can interpret them in the same way. And the idea here is to detect defects in these requirements and then show them to the requirements analyst, who can vet whether a certain statement is actually defective or not. We're speaking about the defect of single requirements, so single statement, but also related to the whole set of requirements. For example, incompleteness. Am I missing some requirements? And also to pairs of requirements. Are these two requirements equivalent, so redundant? And NLP techniques have been largely applied to this type of problem, and I will show you also some example about my work on this topic. But the most recent work is again at ASE, and they are actually tackling one specific type of ambiguity problem, that is syntactic ambiguity. So ambiguity related to the syntax tree of the sentences, and they are reaching good precision and recall. In this case, they are not using BERT. So for defect detection, it seems that good performance are achieved thanks to well-defined more classical NLP heuristics. And this was at ASE this year. Another task still in our quick trip that we see in our quick trip is glossary extraction. Glossary extraction and in general relevant term extraction from documents. For example, I have a large set of requirements and I want to see what are the relevant terms that I want to include in my glossary, or I may want to include this term as labels for my categorization, or I can use them later on for model generation, because I don't want just to generate term, but also relationship between relevant terms, so that I can build a model. Model generation, also called, like in this slide, model synthesis. You have several requirements, you extract the entities, you link the entities, and you have a high-level model that can allow you to have a better view of your problem and a better view of the entities and relationship that appear in your specific problems. There can be also the case where you have very detailed requirements and you want to extract more fine-grained, possibly behavioral models like sequence diagram, or structural models like feature models. This is was studied also in product lines engineering, which has some link with requirements engineering. All these can be useful both for documentation, but also for requirements analysis, because of course, visual models provide a more comprehensive view on requirements, because requirements, you read them sequentially, one after the other, while a model comes to you as a whole, so as an entire artifact, okay, that you can read all together. And about model synthesis, this is not, let's say, a hot topic because it's hard in itself, okay? One paper was in the RE journal in 2020, and they were, in this case, applying deep learning techniques for extraction of relevant entities to be used for model generation, and they reached variable results from 30% to 80%, depending on the type of entity that they were focusing on. And we pass then to other topics that are not strictly focusing on classical requirements document, let's say, and are more related to legal documents. For example, the task of regulatory compliance. I have a set of regulations that have an impact on my software, and I want to extract, also in this case is a problem of information extraction. I want to extract, for example, actors, actions, obligations, constraints, so relevant entities, and then define my requirements based on these relevant entities, or check whether my requirements actually match what is written in the regulation. It can work also the other way around. We see that there are a lot of studies about the analysis of privacy policy that come with the application, with mobile apps, and we may want to extract what type of sensitive data are collected by this type of application, or whether there is some ambiguity in these applications, and you want to check whether the privacy policy is in agreement with the regulations. Also, in this case, it is an information extraction problem, and also a problem that is related to matching the content of the extracted information with the content of the regulation. And there is also another paper at RE 2020 about this topic. They reach for extraction of and classification of requirements from software engineering contracts. They reach a precision around 80% and recall around 90%. Again, in this case, they're using BERT. So you see that it is quite dominant, except for a few cases. And finally, our task about our final task, that is user feedback analysis. This is a task that has several works focusing on it. And the basic task is understanding whether in the large amount of users feedback that you get for a certain app, so large amount of app reviews, whether there's some of these app reviews that contain relevant requirements to improve the app, so to refactor it or update it. This is the basic task, but several other tasks like studying the rationale or extracting the actual requirements from the reviews have been developed across the years. Actually, the most recent paper on this was published at ASE this year, and they use BERT to match bug reports and related app reviews. So the viewpoint of the users with the viewpoint of the developers. And interestingly, they also found that in many cases, the users were able to find bugs before the actual developers. So this is also another interesting read. Of course, they're using BERT. Okay. Some observation to wrap up this initial part of my presentation. So most of the RE problems that I presented to you very quickly could be solved top down, because I could enforce tracing when writing requirements. Okay, I can do it manually. I can also use constrained natural languages to improve quality. Why should I detect ambiguity if I can constrain the language so that ambiguity is not there? I can also tag classes in advance, so I don't need to do automatic classification. I can write a glossary in advance, like it is recommended practice. Unfortunately, this does not happen because requirements also change very frequently. And so it's very hard to do these very structured activities while you're writing requirements. And that's the reason why we need natural language processing to support us in all these type of activities that still remain mostly manual, but having an NLP assistant can deeply improve the quality of your work, especially because we need NLP to recover from errors when requirements problems are actually addressed top down by fallible humans. So you can do mistakes all over this type of activities, and NLP techniques can help you correct this mistake. By the way, use BERT. I'm highlighting this aspect because we did a systematic mapping study that is linked here in the ASE computing surveys in 2020. It was published in 2020, but our collection ended in 2019, okay? And one of the observations of the mapping study was that requirements engineering studies were not using enough advanced NLP techniques, okay? This is not the case anymore, so we should update somehow a part of the conclusion of this study that I anyway invite you to check, because we've seen that many recent studies are actually using the most recent NLP techniques, and in particularly BERT, reaching very good results, okay? So, but now you may ask yourself, but what did you do? You showed us a series of papers. Just one of you was coming from you, and it's even under the revision, and you don't know if it's going to be published. So, what did you really do? Well, I didn't do so many studies, and these studies that I presented here are surely extremely more valuable than many of the studies that I've done, but I have at least some stories to tell. So I will tell you a few stories about my experience in applying NLP to requirements engineering problems. So let's start. I started working on this topic on 2010. After my PhD, which was focused on modeling and code generation, so a completely different topic, I joined the lab at CNR and my current research institution. That was the lab that developed Quartz. Quartz, if you don't know what it is basically a tool for defect detection in requirements, and it appears like that. Like this is the interface. You see that it's quite old-fashioned as an interface, and I was basically asked to improve this tool. So there I came to CNR and they asked me, okay, improve this tool, make it better, make it more modern, let's say. And I asked, okay, can I get the source code? So at least I can reuse part of it. Well, no, you can get it because you cannot understand it. It's very hard. It's better if you don't get it. Okay, so let's at least explain me how is it working. Is it using machine learning? Well, no, it's using just dictionaries. So I understood that basically what it was doing was just was implementing the find features of any word processors, but with specific dictionaries. Okay, so I said, no, this is boring. This is too boring. I can do better. I don't want to improve this tool. I want to do something different. And I decided to start studying ambiguity, which was the topic of Quartz. And I said, okay, I can do better than this Quartz. Let's start from the literature, and let's start from the ambiguity handbook from Barry and Kamsties. This is a reference work from Dan Barry and Kamsties that I recommend you to read, is actually a handbook, a quite long essay about ambiguity with several examples about requirements engineering, about requirements and also contracts, okay? In the literature, an ambiguity is a property of an expression of being interpreted in multiple ways. And there are several classes. I'm not going through all the classes here, but an example can be, an example of class is vagueness. For example, avoid long C functions. You don't know, if you don't put a specific numerical constraint, you don't know what is long in this context. Or generality, for example, when the sentence or term needs to be specified more. For example, the interface should be coded in Java. You don't know whether it's the user interface or the interface of the function. Okay, so you need to specify it more. There are several classes, and the most complex class is pragmatic ambiguity. Pragmatic ambiguity, the definition is here, is the ambiguity that occurs when the meaning depends on the context. So the context is given by other sentences, domain knowledge, common sense knowledge, the viewpoint of the reader, so several aspects. Okay, I said Quartz does not work for pragmatic ambiguity, does not consider the context at all because it's doing find on a document. So I'm not gonna study that. What is a typical case of pragmatic ambiguity? It is this one. I have a guy who's working in an office and he's saying there is a mole at work, and he's speaking to a countryman. Of course, work for him is the work in the office, and for the other guy is the working on the field. So he interprets the term mole as the animal instead of interpreting as the spy. Okay, so the background knowledge of these two people actually give different meaning to the term work and in turn to the term mole. I wanted to study this problem, but there are so many facets in pragmatic ambiguity. Let's focus on just one facet, that is actually domain knowledge, like the case that I was showing before. And the idea that came to my mind was to mimic the interpretation of a requirement by two different subjects who have acquired different domain knowledge. How did I mimic that? I take some domain-specific documents, I build a knowledge graph that somehow represents the knowledge of a certain subject, and then I want to simulate the interpretation of a requirement as a graph traversal, so as a path through this graph. If I do this by using different groups of domain-specific documents, I will have two different graphs, and so I will have two different path traversal for the same requirements. If I do these two graph traversal given the same requirements, and then I compare the content of these two paths, if this content is very different, I can say that there is the possibility of an ambiguity in the requirement. So this is a snapshot of the idea. It was published at RE in 2012. So quite some years ago. And at this point, I tested this just on a very small data set that we developed here. That we actually developed here. We tagged internally here in the lab, but we wanted to work on a larger data set. So and the issue here was that the requirements that we had were also very hard for us to interpret. So we couldn't even tag them for ambiguity because we didn't understand them. So the idea was here we need a data set that we can tag because we understand the requirements, and so we can actually identify the ambiguity. And so here there is another story. To build this data set, I had an opportunity. I had the opportunity to go to USA for 3 weeks with a grant that was given by my institution. And so I went to USA to meet with my colleague that I met some years before, and we wanted to work on building this data set. And the idea was, okay, let's do a set of interviews. Then after these requirement solicitation interviews, we document the requirement, And then we tag the requirements for ambiguity ourselves. Since we performed the interviews and we wrote the requirement, we will also be more able to understand the content of this requirement and also be more able to tag the requirements, or at least check whether the tagging on someone else is sound or not. So we planned for this study. But after the interviews, we saw that there were so many ambiguities that were already present during the conversation, and they were so different from the ones that were appearing in the literature in Dan Barry's book. So in the end, we never wrote the requirements document. We stopped with the interviews, and we decided to extract the ambiguities from the interview audio, so to annotate the actual interview audio. To give you an example of the strange cases of ambiguity, let's consider this slide. Here the customer said, I want the train to stop within 50 meters if a red signal is passed. And I thought, hey, but if a train goes at full speed, it needs 100 meters to stop, so it cannot stop within 50 meters. So I asked, well, this may not be possible if you go at 130 kilometers per hour. And the customer says, well, I meant in shunting mode. In shunting mode, the maximum speed is 30 kilometers per hour. So your requirement would actually make sense. So this type of ambiguities seem to be strictly connected with two other phenomena that are incompleteness, because he didn't say that he meant in shunting mode in the beginning, so he provided incomplete information, and also inconsistency, because I saw that what he said was inconsistent with my previous knowledge, and this allowed me to say, hey, this looks ambiguous to me. Okay, so ambiguity seemed to be related to incompleteness and inconsistencies, okay, and be related to not just the interpretation of a requirement, but also the relationship between the two subjects. And that's why we decided to develop an overclassification of ambiguity that is specific for requirements elicitation interview. And this is the paper that we published first at RE and then in the Requirements Engineering Journal. And I invite you to read the paper, because I think it has a lot of interesting examples and cases, and the classification covers many cases that you can encounter also in your daily life, okay? Let's go to another story. This goes a bit beyond NLP. So let's go back to NLP. Before the Quad story, I did my PhD in a railway company, okay? And after some years, they contacted me to improve their requirements process. They knew that I was working on NLP for requirements engineering. So they said, okay, we want to apply your techniques in our field. My pragmatic ambiguity detector wasn't really working, never really worked in a decent way, in a way that could be ported to a company, also because we didn't develop the annotated data set. So back to the boring quad style checks and see what it happens, but with a twist. I thought this type of rule-based NLP approaches generate too many false positives, so too many false defects in the requirements. Well, these people are engineers, so why don't they write the NLP rule themselves? These are computer scientists, so they can write the NLP rule themselves, so they can adapt them to their context and will not blame me for the false positives, because if you have too many false positives, you just will say that the tool is not working, okay? So we did this, and two railway experts developed their own rule-based ambiguity detection system with GATE. GATE is General Architecture for Text Engineering, is a tool that is quite user-friendly for information extraction in general, but here we adapted for the context of ambiguity detection. And this domain expert defined a set of detect detection patterns, of course, and they applied on a large bunch of requirements that they knew that they could interpret, and they found a lot of false positive, of course. But then at this point, they were able to actually develop discard patterns, because they were knowledgeable about the domain and about the language. And so they could get rid automatically of the false positive. In this case, Adaptation of the language to the language of the company was crucial, and the involvement of the domain expert was crucial, especially to develop the discard patterns and to understand what was written in the requirement. Okay, so without their involvement, I couldn't even understand this requirement, and so they were able to introduce this tool, and they are still using it in the company. Okay, let's go to another story. And this is a story about the encounter with Word2Vec. The issue of pragmatic ambiguity that I explained to you before still puzzled me. And I had this paper on my desk, on this actual desk for quite a long time, but I never really understood it. This is the paper about Word2Vec. And a friend of mine came to my office by chance, saw the paper. This friend is working on NLP, and he thought, hey, but why do you have this here? This is the next big thing. Why are you working on this? Well, I said, I didn't really understand it. I forgot why I downloaded it. But he explained that to me. And that's how I came to get to know word embeddings with Word2Vec. For those of you who do not know what this technology does, basically with Word2Vec is a way of representing words in a vector space, so that semantically related words have closer vector with respect to unrelated words. So taking requirements and constraint, they have closer vectors with respect to dog. Okay. So I decided I want to use this to detect domain-dependent ambiguity. And in particular, I want to measure the relatedness between a word in a domain and the same word in another domain. So I want to check that the word code in computer science is associated to source code, while the word code in medicine, in the medical domain, is related to identifier, and it is actually a code treated as a convention. Okay, so they have different meanings. How did I do that? I built domain-specific word embeddings by learning these word embeddings from domain-specific Wikipedia portals. So a lot of documents all belonging to the same domains, and I came to define these domain-specific word embeddings. Then I brought basically after gathering all these documents, I was able to bring them with some magic that you find in the papers, of course, on the same vector space. And I was able to compare the meaning of code in computer science with the meaning of code in the medical domain, so that I could measure the distance between these two words in these two different domains. Of course, this is a very quick list of stories, but I have also other stories that are for other moments, for example, related to application to requirements in NLP for requirements completeness, to improve the structure of the requirements, and also application to product lines engineering with works on mining commonalities and variabilities in product lines. Of course, these are other works that I've been doing on application of NLP to RE and software engineering in general. So what's next? Well, let's go back to our first statement. At the beginning, we said requirements are typically written in natural language, but well, when they are actually written down, because we know that in many cases, requirements, except you are in those cases in which you are forced by the norms, by the safety critical norms to write down your requirements, in many cases, you don't write them down, okay? So we need to consider that requirements come with different forms. So speech, interviews, but also videos from meetings, and also data analytics, because requirements are also coming from the usage that people do, or diagrams, models that you can get, okay, that you develop across the process. So we need to, as requirements engineers and software engineers, we need to make a step forward and try to go beyond natural language requirements and try to mix the natural language aspects with multimodal aspects, so visual aspects and sound aspects. And this is the next challenge, I think, for NLP, for RE, so to become multimodal. And also in this case, again, maybe also use BERT and try to see if it works out. In this sense, we made a recent contribution that initially was planned to identify ambiguity again in requirements interviews, so to see whether the interviewee, so the possible user, was actually understanding the question of the requirements analyst in a correct way. And we wanted to check this by monitoring monitoring some vital parameters with a wristband and with the sound, so by recording the voice. But we understood that this didn't work actually. And because ambiguity, also the perception of ambiguity is just a moment, okay? It's not something that you can feel with a wristband that is measuring your blood pulse. So we understood that probably it was more applicable to focus on engagement. And that's what we did. We designed a very nice experiment to understand whether during the interview the user was actually excited or he was bored. And this is still in archive. It's using voice and biofeedback to predict users' engagement during requirements interviews. It is an extension of a paper that we published at Requirements Engineering Conference that was focusing solely on the usage of the wristband. In here, we are using also the voice of the user and try to understand emotions from the voice. And I think it's a good direction also for requirements engineering and software engineering, because we do meetings, we do conversations, and there is a lot of information, also emotional information, that is passing through this conversation. So to wrap up and close this keynote, so I showed you some research ideas that I'm proud about. So you can probably, they are not so impactful, but at least in my opinion, they are nice. So what are the key ingredients of research ideas? Can you say funding, knowledge, or intelligence? Well, I never had funding just for doing the trip to United States, but no large funding, and knowledge is limited. I couldn't even understand the paper about knowledge and intelligence, of course, are limited because I couldn't understand the paper about Word2Vec. So you can understand that the key ingredients are actually different. And they are curiosity, but also chance, because we did a lot of mistakes in this path, and we came to new ideas by mistake, by chance. And of course, good company, because all of these works could not be possible without these people. There is, of course, many people are missing here, but these are recent and past collaborators that contributed to the works that I discussed and introduced here. Okay, so thank you very much for listening. And if you have any question or you want to discuss about things or clarification, I'm here for you.
Thanks a lot, Alessio, for the very interesting keynote talk. So I would like to open up now for questions and discussions from the audience. Yeah, Sridhar, please go ahead.
Yeah. Hey, hi. Thanks, Alessio. Wonderful journey of how things have changed in this space. So a couple of queries, primarily in terms of the domain knowledge and the contextual knowledge that is required. So these days, I'm also hearing about the ambiguities within the domain. So like cross-domain ambiguities. But now, they're also saying intra-domain ambiguities. When I talk to industry people, they keep saying okay, and also, I mean, that's one thing. Like, how do you see intra-domain? Is there some work done on intra-domain, detecting intra-domain ambiguities? That's one question. The other thing is, how do you see the context playing role? Say for instance, if I have to model requirements or the NLP techniques, if I use them for a large company, let's say like Microsoft, versus let's say there is a startup, and then the way they do requirements. So is it modeled somewhere, or are there some examples or strategies to address that?
Yes, these are very good questions. Concerning the domain specificity and intra-domain ambiguity, there is the work that I mentioned at ICSE that is actually working on specific documents from a domain. So it is addressed and it is discussed, but look, they are working on syntactic ambiguities. So some very specific type of ambiguities that are related to the parts 3 of the sentence, okay? And in my opinion, of course, for the ambiguity that may occur in a specific domain. So I have two developers that know the domain and they have a different interpretation within the domain. Still, the list of bad words, let's say, of unwanted words that are provided by Dunbarry in their early work are still good enough, okay, for even for industrial practice. I mean, as for the practices and the NLP between different companies, of course, there is a huge gap. I don't know about works that are actually comparing these different type of situations. So it would be really, really interesting to know what is the difference between the requirements document or requirements practices in large company with respect to small companies. Of course, it doesn't just depend on the size of the company, it strictly depends on the domain of the company, because if you are a safety critical company, you have to write your requirements down in a certain way, and you need to make sure that they are rigorously written. If you don't have a mission critical product, that is not that is less relevant. So you have really different types of requirements. So yes, considering the initial slide, it's like the context matters a lot, matters in the way that you write requirements, and it has an impact, of course, on the types of ambiguity that you find in the requirements and the tolerance that you can have for ambiguity, because you have to live with ambiguity and inconsistency, of course. But there is different scales depending on the company of how much ambiguity can you tolerate. I don't know if I answered your question, but
no, I think thanks Alessio. If there is a link for intra-domain ambiguity, if there is some paper, can you post it in the chat if you are aware of?
Yeah. There is
that'd be great.
Yeah, just going back. This should be sorry. Yeah, domain-specific corporal to improve the handling of ambiguity in requirements.
Okay. All right. I'm gonna check this.
Okay.
Thanks.
Yeah, you're welcome. And also for domain-specific ambiguity, not really related to the domain, but that are let's say applicable in safety critical context. The list from Dunbarry, he has a list of words that you shouldn't use in requirements. Is still good.
Okay, thanks. Thank you.
Thank you. And then we have another question, Dr. Ramzan. Please go ahead.
Yeah, thank you so much. And Alessio, thank you so much for such an insightful study. Actually, I have a student of mine working in a similar kind of domain, and somehow we came across one of the papers written by Alessio and his team, and there was a statement which I have actually written with me, and it was a very startling statement, honest statement, and I just wanted to have his opinion about elaborating it more. In one of the papers, Alessio, you wrote that it was a mapping study actually, and you wrote 130 new tools have been proposed to support a range of linguistic analysis. Sorry, I'm reading it from your paper. Linguistic analysis tasks, but there is little evidence of adoption in the long term. So it is a very timely observation that you had made here. My question was, in your opinion, what factors are going to play a critical role in development of a tool or a technique which could have a true potential, we can say, at industrial level or at long-term level? What factors do you see are going to be critical in that?
Well, this is a very good question. I think that the main factor in the end is the degree of maturity of the tool that is proposed, because in many cases in research we develop tools and then we don't maintain them, and then many of these tools are just just for the sake of publishing the papers. Me, myself, I do the same, because of course you are not a software company and the maintenance of the tool is a problem. If the tool is industry ready, it means that you have support for bugs. It means that you have some developers that are actually taking care of interacting with the companies and improving the tool. So you are not a researcher and you are a software company. This is actually happening because there is a QRA corporation that has developed a research assistant, which is a specific tool for requirements analysis. And on the other hand, there is also Qualisen, which is a team that is working on requirements engineering, and they are also providing this tool for requirements analysis. So one of the main issue is the maturity of the tool. So really tool packing. On the other hand, there is also an inherent problems related to the NLP techniques that need to be sufficiently domain specific. In my case with the company, I asked them to develop the rules themselves for their own requirements. Domain specificity, each domain and each language, each technical language is different from company to company. And having general purpose tools trained on large corpora that work on your specific domain is very, very hard. Now we are seeing some steps toward that direction thanks to BERT and fine tuning, but still we are not there. We are not solving the industrial problems with the domain specific language that is used in specific industry. These are, I think, the two key factors for making a step forward and have more industrial adoption of NLP techniques in requirements engineering, at least. I don't know if, did I answer your question?
Yeah, Liz, perfect. Thank you so much. These will be very insightful for me in future as well. Yeah, that's it. Thank you.
Thank you very much.
Any further questions to Alessio? If not, then thank you once again for the very interesting talk and being here with us. I stop recording now.
Okay.